Our first short talk for this session is Andrea Pritt and Brianna Wham from Penn State University with their presentation, Examining Research, Data Management Awareness and Practices of STEM Research Faculty and Graduate Students across Penn State University campuses. Feel free to start sharing your screen and take it away. Thank you so much.
Great, thank you, Erin. Hi, everyone. My name is Andrea Pritt, and I'm the STEM librarian and the Data and Collections Coordinator at the Penn State Harrisburg Library, and I use she, her pronouns. I'll let Brianna introduce herself quick.
Thanks, Andrea. Hi, everyone. I'm Brianna Wham, and I'm the Research Data Librarian STEM and the Data Learning Center Manager at the University Libraries at Penn State, and I also use she, her pronouns.
Great, thanks. And we appreciate the opportunity to present to you all today. And we'll be sharing our research from our Research Data Management and Awareness and Practices study that we conducted of STEM faculty and graduate students. And as you all probably already know, academic librarians have been on the forefront of offering these research data services to our local institutions or our local communities. And yeah, we can go to the next slide, Brianna, thanks. Thus, a major task for librarians offering these services is to provide support and training that covers varying data management tasks and needs of our researchers from different disciplines, different career stages, as well as campuses. So Penn State University offers an ideal environment to explore differences in RDM awareness and practices between STEM disciplines, career stages. Here we're focusing on graduate and faculty, as well as campus environments, because our university includes over 20 unique campuses. And across the university, there is a great deal of variability in campus size, as well as the presence of graduate degree programs and research focus. So for instance, our campuses range from just a few hundred students at one campus to our University Park campus, which has approximately 50,000 students. And additionally, only 5 campuses offer graduate degree programs, and research is a priority at some campuses, while teaching is the main priority at other campuses. And therefore, by doing this research at Penn State, we're hoping that these results will offer, generalizable knowledge that can be used to tailor RDM services or RDM outreach efforts at your local institutions. So here on this slide, we are just outlining our research purpose and goals. And firstly, we wanted to gain a better understanding of the RDM awareness and practices of our STEM researchers. Brianna and I both have backgrounds and library careers in STEM, so that was a big proponent of this. Secondly, as a university, Penn State wants to improve research reproducibility and supporting open science initiatives. And lastly, we hope that this research would assist us as the university libraries in identifying new ways to support STEM research at Penn State and faculty research in general. And this is one of the goals in our library strategic plan. So here we also have outlined our 4 research questions, and we will touch upon each one of these briefly during the presentation today. To investigate, we utilized a mixed methods approach by conducting both a quantitative survey and a set of qualitative focus groups. It's important to note here that our presentation is only presenting a small piece of our larger project. So in the next few slides, we're going to address RDM awareness by STEM discipline and by campus size, as well as our results, some of our results from the STEM researchers' practical RDM skills. We asked over 40 questions in our quantitative survey, a mix of multiple choice, or they could choose several answers, as well as open-ended. And then we asked 7 open-ended questions in our focus groups, though we're only reporting on a very small subset of that work. We're not presenting on other pieces of the research, such as some of the research workflow diagrams we asked our focus group participants to draw for us. And additionally, we're not going to have time to discuss that. We also asked our survey respondents to define data management in their own words, so we could check the terminology and compare it between librarians' terminology versus perhaps discipline specific. But if anyone has any questions or further interest in our project or our results, please definitely reach out to us, and we would really be happy to elaborate and potentially collaborate more. So here on this slide, we show our survey participation by STEM discipline. We had 365 completed survey responses. And here, the larger the circle that you see indicates the more responses from that STEM discipline. And because Penn State is so large and we offer so many STEM programs, we grouped these into the 5 more general categories that you see here on this slide. So our hope was that by doing this, we could compare our results from Penn State to results from other institutions who have completed RDM awareness or environmental scans. And this slide here, just note that it includes our participants from all career stages. So that's faculty, postdoc, as well as graduate students. And now I'll pass it to Brianna.
I'm muted. Thanks, Andrea. So we're going to dig into some of these results. And in these results, you're only going to see our responses from faculty and graduate students, as we had very few postdoc responses. And so ultimately, we wanted to better understand if researchers are aware of the concepts, as well as the terminology commonly employed by librarians when discussing research data management. So one of the questions we asked survey participants was their awareness of the FAIR principles. And as Andrea mentioned, we also asked in other questions for definitions, such as terms of data management and metadata. And in this question, we did link to the FAIR principles. So we also hoped that this question could act as a learning opportunity for participants that were unaware of the principles. So looking at this chart, on the x-axis are the various disciplines represented by kind of icons representing those disciplines. And on the y-axis is the percent by that discipline by role. So if, for instance, you look at the faculty in biology, the no and the yes are going to add up to 100%. And so what you can see here, looking at our responses, is that nearly 75% of all STEM disciplines and career stages were unfamiliar with the FAIR principles. We also wanted to ask participants to assess their familiarity from very familiar to moderately familiar, which we defined as I've heard of it, or to not familiar, with various RDM competencies from Carlson et al. 2011. And these were also utilized in a similar survey that we're hoping to be able to compare our results to. So these competencies included databases and data formats, discovery and acquisition of data, data management and organization, data conversion and interoperability, quality assurance, metadata and data description, data preservation, data processing and analysis, data visualization, data curation and reuse, cultures of practice, and ethics and attribution. And each of these had definitions provided within the survey. And we're hoping that we can compare our results from these competencies to other results in future research. So looking at these plots, to orient again, we have on the x-axis the discipline, and on the y-axis is that percent within each discipline within career stage. And what we're showing here is those that have identified their level of competency as very familiar. So on this first slide, we can see that researchers' familiarity with databases and data formats, data discovery and acquisition, data management and organization, data conversion and interoperability, quality assurance, and metadata and data description is fairly low. Across these disciplines and career stages, there's about 50% or less with some variability by discipline that said they were very familiar with these competencies.
5 minutes.
Thank you. And looking at these other competencies, we can see that there is some more familiarity with things such as processing and analysis and data visualization, as well as ethics and attribution. Additionally, we are interestingly see that across the majority of these competencies, graduate students in mathematics ranked themselves as very familiar more often than faculty. But further explanation is needed to understand this, to determine if this is a result of graduate students ranking familiarity differently than faculty, or whether graduate students are now receiving more training or have more advanced technological skills in these areas. So we also wanted to look at our data by campus and how campus size impacts research data management awareness. So here's kind of our survey participation by campus, as well as we grouped our campuses into small, medium, and large. And again, looking at that question of are you aware of the FAIR principles, we can see that there is some effect of campus size on awareness of this RDM concept, with larger campuses having slightly more awareness. However, the smaller campuses also had fewer respondents, so this could be an artifact of that. In our survey, we also wanted to assess how the university libraries could improve research data services for STEM researchers. So we asked them first how they primarily learn their RDM skills based off of the options they are provided on the x-axis. And what we can see here is that across all the different disciplines and career stages, the majority reported that they are self-taught. We also asked whether they are aware of that the university libraries offers assistance, and the results were fairly split, but more were unaware than aware. And we also asked about what type of training they would be interested in. And you can see here that the top 3 topics selected based off of count were developing a data management plan, documenting research data, and creating metadata for research. And lastly, we asked in the survey about what format of training they would be interested in participating in. And we found that they were most interested in tutorial videos, webinars, and presentations.
Great. So here we're moving into our focus group results, and you can see again our focus group participation by discipline. And in total, we had 36 participants, 22 graduate students, and 14 faculty members. However, on these slides, you are seeing only 34 participants because we had 2 participants who actually were in like STEM adjacent disciplines. One was similar to like an audio engineering. So they didn't fit exactly into our classic STEM categories. And we just want to note as we go through and finish the slides that the number of our participants by discipline varied quite a bit. And so for instance, on this slide that you're seeing for math, we only actually had 1 participant in that. So when you see later that it says 100% of math people, right, or participants, that means it's 1 person. So here on this slide, we're focusing on the participation by campus. So this was maybe a bit underwhelming for us since we only had folks from 5 of our more than 20 campuses, and all of the graduate students were from University Park. And that makes sense just because University Park's pool of graduate students is the largest, but it was a little disappointing because 4 other Penn State campuses do enroll graduate students, and we didn't have the opportunity to chat with them. What is interesting to note is that of the 5 campuses here, we do have variability in size. So we had 1 large campus, 2 medium campuses in Abington and Behrend, and then 2 smaller ones, Schuylkill and Scranton.
1 minute.
Great, thank you. And so here's one of our last slides. This chart is actually flipped a little to fit better onto this slide, but on the x-axis, you're going to see the percent of focus group respondents by the discipline. And again, just remember that there was only 1 math focus group participant, but along the y-axis are the different data management skills that we asked them about. So we asked each participant to rate themselves as either good, needs improvement, or I don't know, or that's not applicable to my research. But this slide is only showing the needs improvement responses because we thought our attendees might be interested in where these STEM researchers are looking for the most assistance. And the focus group results are in line with the ones we found from our survey, where participants indicated that they would need assistance or like assistance with creating data management plans, as well as data curation and management or data description. And here on our last slide, we just have a few conclusions from the results. Overall, this is probably not surprising to you. There seems to be a gap between knowledge of RDM concepts and how to actually implement them. Though not much different, the computer science and data science researchers have indicated that they are more aware of these competencies than other STEM researchers, and that STEM researchers at smaller campuses generally have less awareness of these practices. But across the disciplines, STEM researchers are primarily learning RDM through self-instruction. And we believe this is an opportunity for RDM librarians to create asynchronous materials to help with that process. And from both the survey and the focus group results, we found that across the career stages and disciplines, most STEM researchers were not aware of the FAIR principles, and that they do seem familiar with data discovery and acquisition, as well as data visualization and ethics of data. Whereas the STEM researchers across the disciplines and career stages are less familiar with data conversion and interoperability, data preservation, as well as, again, data description and the metadata for research data. So these results indicate to us that there's a lot of opportunities for us to meet the RDM needs, whether those are educational needs or technical needs within our university. And it's clear that since not a lot of our STEM faculty are aware of these FAIR principles, this is probably indicating that they may be putting their data in these open data repositories, but there may not be or probably aren't applying the FAIR principles to their data. And I know we're a little bit over, but the next slide is just if you have any questions for us, we're happy to answer those now. So thank you. And I actually see there's one question in here that I can read. It says, when is this study of yours coming out? And if it's in a publication or a repository? So Brianna, you want to take that?
We're working on it. It's probably the best answer we can give you. So we are in our kind of primary stage of data analysis, and we're working to write it up and publish it as soon as possible.
Great. Yeah. So please stay tuned for that. The next question says, by being more or less familiar with the RDM competencies, do you mean they know these are competencies or they feel more or less competent in these areas? And I think it would be the latter here, that they feel confident in these areas. We did ask on that scale, and I'd have to look back, if they felt very familiar where they had only, or very familiar, they were practicing it, or moderately familiar, which was, I've heard of that, but I'm not actually incorporating that into my research work or my data. And then we had a few other ones like, I have never heard of that, or this doesn't apply. Brianna, did you want to add anything?
That was exactly right. And I was just going to add to the question about publication is we're always happy to discuss our results or share results prior to that as well, if you're interested in talking to us.
Yeah, so we have another question here. Very informative talk. I'm glad, and it says, I'm curious about how you made your graphics. So I will toss that to Brianna, who did most of that work for us.
Yeah, I can answer that question. So the graphics were primarily created in R, and happy to share that code that we use to convert our survey results, which came out of Qualtrics, into data that was wrangled to be able to make such graphics. And then some of the kind of icon aesthetics were added in PowerPoint.
Great. Yes. Thanks, Brianna. And I see there's a comment in the chat that says asynchronous materials, except for text-based LibGuides. I think we could be doing more in that space too, but making good video content is hard. And I will completely agree with that. And I think Brianna would too. We actually heard in our focus groups that graduate students would really like hands-on, like visit my lab to teach us, whereas faculty were really interested in like short bite-sized podcasts that they said that they would listen to on their way to work or when they were walking across campus. And so I think Brianna and I would really be interested in working on that, and we would love to be offering more classes or instruction in this area. But it's a lot of opportunity for us, but then of course everyone wants something different maybe, but thank you. Yeah, I would agree.
And if anyone wants to collaborate on creating such content, we'd be happy to chat about that as well.
There's one more question in the Q&A I think we just have time for.
Sure, perfect, thanks. It says, it seems like the split between very familiar and unfamiliar was between data science and data curation or management. This makes sense because they are scientists with working knowledge of data. Should librarians focus more on the latter, RDM, rather than data science? And I would agree with that assessment there. I think, at least for me, I am a science librarian, by training and by nature. I'm not a data librarian at all. So Brianna is definitely more aware of the technical aspects of all of that. So as far as me and my role as a science librarian, I could definitely support the educational needs. But I think Brianna, as a tech expert here at our university, would be able to help with the data science part too. So I don't know. Yeah, I think now we are at time. So thank you very much, everyone.
Thank you.
We're looking forward to the rest of the talks.
Great. Thank you so much, Andrew and Brianna. Our next talk is from Paulina Chris and Cindy Shin also from Penn State University. Their presentation is Data Analytics and Visualization Services in the Libraries. Take it away.
All right. Hello, everyone, and so welcome to another presentation from Penn State University. We are really excited to be able to present our work here today. My name is Paulina Chris, and I am a data analytics and visualizations assistant. I'm joining you today with Cindy Shin, who is our data analyst, and together at the Research Informatics and Publishing Department at Penn State University Libraries, we are working to provide services for data analytics and visualization. So let me start by giving you an overview of our department. The Department of Research Informatics and Publishing at Penn State Libraries enhances the technology-driven teaching and research capacity of the Penn State community. We partner with students, with faculty and staff across all campuses. Our services and centers within the department include the open publishing services, the digital humanities services, maps and geospatial information, the data learning center, and the digital collections. So our department supports researchers throughout all phases of the research lifecycle, with the data services starting from the data management through data collection, data analysis and visualization, moving on to publication and data sharing, data curation, and data discovery and reuse. So Cindy and I are part of the Data Learning Center, where both of us mainly focus on the data analytics and visualization services. We are available to answer questions and provide project support via email and one-on-one consultations. We also provide education in form of the workshops and the guest lectures. We also established the Advanced Analytics and Visualizations Digital Lab. So let's talk about all of these offerings in a little bit more detail right now. The digital lab is a physical space located at the Pattee Library, which is one of the 36 Penn State University libraries. Currently, this lab space can be accessed remotely by Penn State students, staff, and faculty. This computer lab space is equipped with 3 laptop workstations in the Solstice, and it is designed for those seeking specialized data visualization and analysis software, including ArcGIS, MATLAB, SPSS, Microsoft Power BI, just to name a few. At the moment, all of our consultations and workshops are happening remotely. And that's actually a good thing, because that enables us to work with departments and colleges across various locations. We are able to provide our services equally to everyone who is interested, regardless of their location or the campus that they belong to. You might be wondering who our patrons are. So about 30% of our consultations are given for the faculty members. Another 30% also goes to staff. Graduate students are about a little bit above 28% of all the patrons that are coming to us for consultations. The undergraduate students and the postdocs are rather a small group that schedules consultations with us. When members of the staff are coming to us, they are typically discussing their work projects. Graduate students and faculty are coming with issues with their or questions about their research projects, or sometimes even grant development. The undergraduate students are typically coming with their class projects. Apart from the consultations, as I mentioned before, we are delivering workshops and guest lectures. So here you can see all the workshops that we are offering this fall. So this was a part of a new news release that we had at Penn State. We have already delivered the introductory level workshops for Tableau and Power BI, and we will be delivering workshops covering more advanced features of these tools later this month. We are also partnering with Penn State Cloud Services team, as well as third-party vendors, to deliver workshops and guest lectures on big data analytics on cloud. Since we are a data analytics and visualizations team, we created a dashboard to give you a summary of workshop participation data. And I'm going to take a little moment to talk about that. So let's start with the top left corner table. Each square in that table represents one workshop, and you can see over here the tool that was presented or that was taught during the workshop. Since spring 2020, we started gathering the data in spring 2020. And since spring 2020, there were 16 workshops offered throughout all the semesters. And we had more than 760 people who signed up for them. So let's talk about this bottom table for a moment right now. So here you can see that the highest number of people attended the workshops related to Tableau and Power BI. Power BI was in fact one of the most popular workshops among staff, and the Tableau workshop was more popular among students, and also Tableau was more popular for faculty. Tableau was more popular than Power BI, as you can see in that table over here. So when we take a look at the total number of participants right over here on the top right corner, we can see that in general, our workshops were more popular among staff, followed by the students. And in fact, until fall 2021, so we're moving on to the last chart in the dashboard, the students and faculty, you can see over here in 2020, the faculty and the students were rather a small group of our participants. We made additional efforts with promoting our events this semester. So as I said before, we sent a university-wide news release. We also made connections with other departments and personally reached out for help to certain individuals within Penn State and asked them for help in promoting our events. We believe that this was helpful in increasing the number of workshop participants, and this can be seen especially in the student category, because you can see that in fall 2021, we had 179 students who were signed up for our workshops, and it's a huge increase as compared to the previous semesters. And that increase actually holds true for other categories, so for faculty and for staff as well, but it's particularly important for us in the student category this year. All right, so we can help our patrons with a variety of software applications for data analytics and visualization. And our initial process for selecting the tools we want to support was based on the Gartner report. This report consistently presents Tableau and Power BI as the top analytics and business intelligence platforms. Our team started with providing consultations and other resources for Tableau. However, we quickly realized that Tableau was quite problematic because of the licenses, right? If you are not familiar with Tableau licenses, I just wanted to mention that faculty and students can apply for a free license, or you can just use Tableau Public, which is free regardless of your status. But there were a lot of employees within Penn State who wanted to use Tableau, but they were neither the students nor the faculty, so they couldn't apply for a free license. But going with a free Tableau Public was also not an option because their data required higher levels of security than Tableau Public could guarantee. So that's when we started offering support for Microsoft BI as well, Microsoft Power BI as well, to leverage those existing resources, because Power BI is a tool that is a part of the Office 365 license, which Penn State was already paying for.
5 minutes.
Okay. So our data indicates that patrons still reach out to us for help for both Power BI and Tableau, and so people are still using both tools. And as you remember from the workshop participant summary dashboard, we had a kind of a division here, because Tableau workshops were attended more by students, Power BI more by staff. And when we analyzed some of the reports, including data from the job market, we could get some additional explanations for that situation. So when we decide on our service offerings, the job market is also something that is influencing our selection process. So let's take a look at that chart. This chart shows that Tableau is one of the most commonly listed technology skill in data scientist job listings. It's definitely one of the tools that employers are looking for data scientists to have experience with, and there are more than 50,000 companies that use it. We have students reaching out to us for help to help them find learning resources and workshops after they start their internships, and that's the moment when they realize that the company that they are working for uses Tableau or Power BI, and they need additional support to learn how to use these tools because they were not exposed to these tools during their classes, not exposed enough. As a part of our outreach initiatives, we are partnering with other units and event organizers at Penn State. Before I mentioned the Penn State Cloud Services team, we are also participating, for example, in Data Fest as the judges for the contestants. We are also communicating with student organizations across campuses to deliver workshops on data analytics and visualizations specifically for their groups. We are also involved in supporting Power BI Community of Practice, which is a newly formed group at Penn State that shares experiences and resources related to Power BI. In general, I have to tell you that collaborating with others helps in making our services better discoverable for students, for faculty, as well as for staff. But it also helps us better determine the scope of the services that are needed within our community. The demand for our services, for the data analytics and visualization services, is very high, and it's constantly growing. So with that, I will move on to the questions if we have any.
Thanks, Paulina. There's one question. I think you did partly answer this, but if there's anything more you wanted to say about Power BI and why it's so popular at Penn State?
I think that the main reason is that we have a lot of members of the staff community, so the employees of Penn State University that really are doing excellent job with their reports. A lot of reporting goes into the dashboards, and it's really a great tool to use for reporting. So people just want to be able to do that, and since they are not able to get the free license for Tableau, they are just switching to Power BI, and that's where the popularity of the tool comes from.
Thanks. I don't see any other current open questions. We do have a couple of minutes, so I'll give folks a little time in case something else comes to mind.
Sure. Yeah, and thank you so much for the opportunity again, and let me know if you have any more questions.
One more question just came in.
Could you say a bit more about the skill set of the workshop instructors? I am actually one of the instructors. So my background is in computer science and econometrics. I did programming, but I did not use extensively tools such as Tableau or Power BI during my college times, right? I did learn a lot about how to think about data during the college times, but again, a lot of the skills that I acquired was during the time when I was actually preparing the workshops. So that's when you realize what you don't know and what you should tell others. So there are things that you learned before, but again, when you are preparing those workshops, you kind of learn on the fly. I agree with one of the first presenters, like you don't need to be an expert, because we just need to be experts in searching for the information that we need to find for others, right? I hope that answers the question.
We've had a couple more come in to the Q&A. Can you see those?
Is the university's Power BI license full, as in users can share dashboards online? Yes, you can. You just have to ask for special permission. So it's not like you can just do it right away. You have to reach out to certain services to ask for the permission to be able to share that with others. I think especially with others outside Penn State. I didn't see if Power BI was noted in your slide of what's asked for in job ads. I think I actually didn't specify that. So we just talked about Tableau, but we still look at that. So I cannot give you specific data right now, but we do take a look at that for sure. What type of RM training would you be interested in? And how do you advertise the availability of the digital lab? So with the digital lab, like we are just sharing that. So right now it's a little bit more challenging since we have the remote access to the lab, but people just know that if they reach out to us, like they're asking about the specialized software, we are just letting them know that they can use it. We are not specifically advertising that, unless I'm mistaken. Maybe Cindy will be able to share more insight about that at the moment. How do we keep up with so many visualization tools? Well, so I am the primary person to reach out to when it comes to questions about Tableau. Xiang is so Cindy is our experts on Power BI, and that's typically how we split with those two. And then when it comes to the rest of the tools, we just have some experience with that from the past, and just try to do our best, right? Any other questions?
Looks like that might be it.
Great.
Thank you so much.
Thank you so much.
Excellent. Thank you so much, Paulina and Cindy, for that presentation. We've got a couple of minutes extra time, so if Mandy and Jeremy need some time to gather themselves. But our final short talk for the day is presented by Mandy Swigert-Hobaugh and Jeremy Walker from Georgia State University. They will be presenting It's Big, It's Messy, and It's Complicated, an assessment of big data research support needs. Thank you.
Hi, everybody. Welcome. We are Jeremy and Mandy, and I'm gonna and we're presenting on it's big, it's messy, it's complicated assessment of big data research support needs. So I will turn over to Jeremy now to begin.
Yeah. Welcome everyone. The thing we're going to talk about is our little subsection of a much bigger report. So over the past year, Ithaca SNR has been sponsoring, organizing, coordinating a study called Supporting Big Data Research, amongst many other reports they're constantly working on. Involved in this is our 21 different higher education institutions, of which Georgia State University is just one of the little splinters of the project. So the idea of the project is like all of the institutions would go out, do some interviews, and collect information in support of the core research questions, which like conveniently align with a lot of our very local specific interests here at Georgia State University. So with that in mind, I think Mandy has to activate the next bullet point. There we go. So like, what are the aims? Like one of the aims that we had from the outset was like, what are the research needs of quote unquote big data researchers at Georgia State University? Do they need tools, resources, instruction, like, you know, a high five? Like what is it that they need in order to be successful as like quote unquote big data researchers? And also like following that intuitively is like, okay, what can the library do? And Mandy and I are both part of the research data services team at Georgia State University Library. So we have a very direct focused interest in this, but there's also implications for what university library may more broadly be able to do and support as well. So that's kind of the objective that we went into this, this report, this project, this research study with. So moving on, how did we do this? In short interviews, in a little bit more length, we, and this is what all the institutions did as well. We basically canvassed our own campus to look for a handful of quote unquote big data researchers involved in some type of really advanced computational research involving very large data sets, whatever that may be. And then with these researchers, we conducted semi-structured interviews. Following those interviews, we did like a whole bunch of transcription, then qualitative coding. If you're interested in all of the details, the full report for the Georgia State University segment of this project has already been published. It's on our institutional repository. We can share a link in the chat towards the end, I suppose. So if you're really interested in like how we did all of the interviews, the research, and the coding, all of that information is publicly there. So you can explore that at length, I suppose. So, but the core outcome is like, we got a nice mix. We got a mix of social science versus like natural science categories, mostly research faculty, but also some research staff as well from a pretty good array of disciplines. So what did we learn? A handful of things came out of this. So with big data, and we put it in quotes because it means a lot of different things to a lot of different people, and they don't always align. So like one of our core questions with our subjects, the people we were interviewing, was, what is big data? What does this mean to you? And a couple themes popped out, and a couple like things came to the forefront as a result of our interviews. The most important characteristic for the faculty we talked with was volume. Big data often has like volume, velocity, and variety as like the key components of big data. Volume is the one that our researchers noted the most and explicitly. Several of them citing the production of terabyte and petabyte sized data sets every single year, and in some cases for every single sample of data. Just like mind-boggling amounts of information. Next up, another thing that came out was like, and this, like I alluded to this, big data does not mean the same thing to everyone. That there's like an intrinsic paradox between really cheap data that's really easy to collect in bulk versus data that is extremely deep, but also like narrow. You can only collect a handful of samples and they're extremely expensive. And there's like that balance point between, they're all big data and data science-y, but different researchers like noted different sets of problems with the nature of how their data is big. And then another point that came up was that often the transition from traditional analysis, traditional statistics, or even machine learning on a very small level, once these researchers talked about their research graduating to a big data level, they were like intrinsically required to make use of high-powered computing systems and rewriting a lot of analytic code so that it would work in a parallel computing environment, which is not always, it's not a trivial task to make that transition if you're writing like scripts and analysis in like a Python, R, Java environment, etc. So like that was one area. The next slide, and I won't read this to you, these slides will be ready for you later. We didn't have to infer too much most of the faculty that we spoke with were very forthright and very on board with having these conversations. So a lot of them spelled it out extremely clearly, what the challenges were, what some of the contradictions are. Like, and this is from one of the GSU2, one of the interviewees, where they specifically talk about the difference between big data consisting of tweets, which are produced freely and very cheap and easy to store, versus like we have a neuroimaging center here at Georgia State University. A single sample of a brain scan could easily be a petabyte worth of data, and it's not cheap to collect that one sample of data. And that's like literally word for word with like a few like highlights in there for you. These slides will be there for you later. You can always pour through them. And we have many more quotes from in our full report. Another area that came up was like infrastructure, infrastructural needs and challenges. This was a common area of note. Before I get into the critiques, one thing that's worth noting is that almost every faculty that mentioned the high-powered computing unit at Georgia State University had nothing but praise for like praise and like really positive things to say about the staff and the research support people in the high-powered computing unit at Georgia State University. There's some critiques about like the infrastructure and resources, but there were no critiques about the personnel or the support and professionalism. One of those critiques is like, in like critiques and challenges is the raw cost of storing data. Just like for example, the next slide will show this. One sample of a brain scan image, for example, to store that in a cloud environment, which is like the default, in vogue solution on Amazon Web Services, would cost $20,000 US per month. That's not feasible or sustainable. So with that in mind, all that hardware needs to be purchased, stored, and managed locally, which that also brings in a whole host of networking challenges in order to actually transfer and make use of the data. Another point that came up was this analysis, and I've already alluded to this, requires the use of high-powered computing, supercomputing clusters, and one of the consequences of this is that sometimes our researchers will go to other universities to piggyback on their computational resources. Sometimes they'll collaborate with other researchers shrewdly as a way of like being able to access resources we may not have locally. And then in some fields, that's even just common, like with the Exceed supercomputing clusters that are very heavily used by physics, for example. It's just common practice to like outsource the supercomputing work. Next up. And then another critique of the existing Georgia State University high-powered computing systems, HPC systems. They're not the most user-friendly. They are like, they're dense, they're hard to work with, they're challenging, they're somewhat locked down. And several researchers noted that one thing they would like is to be able to just do some on-demand computing. Maybe not, supercomputing stuff to calculate infinity, but like just being able to spin up small scale analyses to at least like prototype their analysis before doing a full batch run. That was something that was requested and commented on by several people that, yeah, we do have supercomputers at Georgia State University and quite a few different clusters, but it would be valuable if they had just a better user interface that was easier to use for both teaching, learning, and research, all of the above. So, and then this is what I alluded to earlier before, like $20,000 a month to store some data in the cloud. Like these are the types of challenges that come up that some of the researchers mentioned was just the cost is astronomical for some of the big data researchers we met with. Next up. I think this is just more quotes. Yeah, talking about like even once you have like a local hard drive that's big enough, or a clustered database, like the cables and the wires that are literally connecting the machines, the network infrastructure is also somewhat lacking. And yeah, again, right from the researchers themselves, they really wish the interfaces for some of these HPC systems were more usable. And then I'm going to turn it over to Mandy for the next couple chunks.
All right, great. Thanks, Jeremy. So to move on to some other areas of needs and challenges, data access. So one common theme that we found is that there were challenges with securing and adhering to data licensing agreements. So licensing agreements would often limit the volume of data that a researcher could access, period, or maybe within a given like iteration of when they were doing searching or doing the access. So that could be kind of problematic. Thank you. So also there's the high costs and often siloed licensing agreements. So we found, people be like, well, my department has a Twitter data set, but, I can't share it with somebody else on campus. And that, impedes potential more research coming out of this data set. So present solution that often happens, again, echoing what we've already heard about infrastructure, is collaborate with researchers at other institutions who might have better financial and infrastructural resources. And so one quote, again, don't expect everybody to read it all, but if you want to, so the full report will be on these slides later. But one researcher proposed, why can't the library maybe invest in providing institutional-wide data licensing access? And he was specifically mentioning Twitter data, and as this I've highlighted or bolded in here. He thinks, if you've got all this data, you're basically fertilizing papers. So you're treating data like a collection that anybody can access. And that we thought was an interesting point. As far as this area of data code and sharing, or people, obviously they expressed interest, like, yes, to promote open scholarship, and being possibly cited by people. It'd be great to share our data and our code. But some expressed concerns about just describing it as scooping or maintaining one's advantage over competitors if they shared their code and or data and not being properly credited for that work. They mentioned, as we all know, preparation, documentation, maintenance of making code and or data shareable is a significant hurdle. Again, licensing agreements, especially our social sciences researchers were working with social media, so they didn't really have necessarily the ability to share their data openly. And then this general notion of this impracticality of particularly sharing big data. So we have this one, it's a big quote, but this was from an astrophysics professor, I believe, I remember, saying that, yeah, a lot of these grants and publications are saying, hey, you need to share your data, but there's no place that will let you save like a petabyte of data and make it open to the public. Like, it's just too big. And so this particular researcher was noting the impracticality of being able to meet these demands. We asked some questions about learning, like how did you learn big data methods? And those things that we gleaned from that is there was a lot of talk about informal learning, so being self-taught or just doing like needs at hand troubleshooting. Semi-formal learning, like forming peer groups or meetups. Formal learning, like what coursework, what workshops did they take. One interesting quote that came from somebody as well was talking about networking opportunities and how this particular researcher found like one particular event called Scientific Computing Day that was held on campus, and another event that the library sponsored where they were just, highlighting or showcasing faculty research was great because this researcher then met other people in other departments that they didn't even know about that were using like similar methods or interested in the similar kind of topics, and that helped them to establish those collaborations. And they said, I like to have more of these kinds of events. Just get us together, get us in the same room when it's safe. And then we will, we will bond and we will go forth and collaborate. Formal learning, thank you. Formal learning that they talked about is that it's hard to get. Some of their departments don't even offer some of these classes, but then then one professor was like, yeah, but even going to like another department to try to learn some of these methods, you might be out of your element. It's just too technical. It's not embedded in your context well enough. So possible paths toward improved support that we looked into. Couching in all these, and we wanted to really think about what's realistic that we could maybe have some kind of impact in, and we call them possible paths to kind of couch it in like, we're going to explore these, but we're not making any promises, frankly. So one thing was data access, since that one professor mentioned something about, can the library manage campus-wide data access and licensing to help alleviate cost and then to provide this cross-campus access. We would like to explore that further, and we think this is something that, regardless if you have a research data services team or a dedicated, data services unit, all libraries could kind of look into this because it's basically about collections. Similarly, building research community, like the one professor said, so trying to just have events or, be the facilitators of meetup groups or something might help bring these big data researchers together. Then I'll turn this to Jeremy, I think, to talk on these last two.
Yeah, so another area that we could feasibly support, the research data services team already teaches workshops in qualitative and quantitative software tools and some methodologies, but they tend to be pretty generic. One thing that kind of emerged from these interviews was the possibility that we could start offering more discipline-specific, grounded, contextualized training support, like research training, mainly to graduate students is the audience that we were aiming at. But we also have to balance that against the fact that the research data services team does not have experts in every field who are specialists in every single tool or method. And also time is a limited resource. So it's kind of challenging that we would have to figure out where the optimal opportunities are, like which departments or which programs could benefit the most from the type of instruction and training that students need in order to segue into conducting big data research in their department. Then the other area, which is in some ways a no-brainer, we do this all the time in libraries, advocacy. Georgia State University, like many other universities, is a big sprawling institution and nobody knows where anyone is. So we're going to be sharing all of our results and reports with the people I referenced earlier, the high-powered computing unit, those staff. But also we need to be proactive or potentially more proactive in communicating when we work with students or faculty who are encountering certain research challenges, advocating for their needs to other units on campus as appropriate. That's an ongoing part of our job, I suppose, but it's worth remembering, and it was validated by the research for sure.
And
with that, go for it, Mandy.
That brings us to the end. So we welcome any questions. We know we went a couple minutes over, but so I see one question in the chat, saying we also participate in the Big Data Ethics Project. One of the takeaways we saw was researchers suggested training on collaborative IRBs, so all researchers at various non-UVA institutions would have uniform IRBs. That's probably a good point, definitely, too, because, the IRB particularly might be the place where we get more into how can we share the data, how can we also maybe share data across institutions and such. So yeah, and if there's anybody else in the audience who also participated in this Ithaca Big Data study, we'd be interested to see or hear what you found, if anything echoed, resonated. Yeah, and as Joe says, that sounds like it would cut down on repetition and repeated work. Are there any, and I see Q&A, I just saw one come in. Did you discuss if there are ways the library, a wider consortium of libraries, can come up with solutions for sharing or archiving big data. So that is one point that you'll notice our possible paths that we really didn't touch upon as much, like how do we deal with the sharing and archiving of big data. Probably some of that stems from our particular research data services team. We, shocker or not, we don't focus as much on data curation and archiving, so it didn't, but I was thinking about that as I was looking back, like what might be some of the solutions, and I'd be open to other people's ideas about this, because I think the big data aspect, that seems to be particularly the big challenge, of like, how do you share all this? And I think that, and Jeremy may be able to pop in too, one of the things that was interesting about what we found with our researchers is that, and this is probably common, but they have such a vastly different data that they're working with. So to come up with some of these solutions, I think would be pretty challenging.
Another set of challenges that come in with that is some of our researchers work with data that has no risks, like it's not identifiable, it's not personable, it's whatever. And then other researchers work with big data that is like public, or not public, like personally identifiable health information. So like suddenly you're up against a huge number of security, ethics, and legal roadblocks with moving your data anywhere at all, much less into a consortial environment. So that would be one of the struggles with creating like a consortial solution. And then another one will probably cycle back to cost, ultimately, because any consortium is going to have data living somewhere else, wherever that somewhere else is. That's going to involve bandwidth, data transfer, which ultimately all results in some cost that it may still just be cheaper for everyone to figure out their own local institutions like solution in terms of like buying their own storage system, because the bill really does rack up on some of this stuff.
And I see we have one more question in the Q&A if and a chat that's related to that. If we have time, we'll just kind of speak to. So the question in the Q&A is, I've been working to cultivate a relationship with our campus HPC staff for some time, and I've found that fruitful. What would you say are some good tips for partnering with HPC managers? And then Jen in the chat kind of echoed this. We've had pretty good partnership too. I mean, as you've seen from the comments, or a summary of the comments, all of our big data researchers that we talked pretty glowingly about the actual staff that work in HPC, because there's one particular person, and maybe a second person, but one particular person whose name came up frequently, and we've collaborated, we've communicated with that person about their getting them, researchers in touch with them if they aren't already, and they're very responsive, very receptive. I think, that's one thing with this report, why we want to share with them, was because, we wanted to make sure they obviously know that they as a staff member are very receptive, very responsive. The issue is the infrastructure, the issue, and then of course that means money for everything, like money to buy and money to pay for infrastructure. So I think just having done this study and being able to share to kind of reinforce some of the challenges that the researchers face, hopefully will prove to be fruitful just in that respect of them having more data to support, what needs to be changed in that area.